curtains, cake, velociraptor,
I'm Discrete.
Tigger,
He's random.
Tigger.
Stop now. Discrete random variables. It's chapter 4.
It is chapter 4. New chapter, so a new intro.
We're in stats, obviously.
We are in stats from
this book.
It's a purple book. Yeah, discrete random variables. It's a very small chapter, but
Yes.
a bit weird.
Yeah, it's not hard stuff. It's just a bit weird to get your head around. That's all it is.
Yeah, it's sort of an introduction into distributions in general,
Yes.
which we'll get onto a
Which is why
lot.
it's so small.
Yeah, we'll get into a lot later. But first thing we should say what a discrete random variable actually is.
It's denoted by x, big X.
Yeah.
That's a random variable.
And a random variable will have set integers.
For example, on a dice.
Your random variables will be 1, 2, 3, 4, 5, 6.
Because they're the possible outcomes that you can get.
Yeah.
And little x
Would be the probability of getting each one of these random variables.
So on a fair dice, that would quite simply be
A sixth, and go on. Yeah.
And you'll see quite a lot the probability that x takes the form little x. Like that.
Yeah. Where you'll have a big X will take a four-letter number.
Yes.
And they put this into tables.
We do, all the time.
All the time.
Shall we stick with the dice example for the second?
I think, yeah, we'll take the last example for the second.
Okay. So we normally have x on the top.
Right, we have X on the top.
This is big X.
Big X.
Um,
These will be our set values, so it's 1, 2, 3, 4, and 5, and 6. And then the probability that X equals little x on the bottom, which is just a 6 the whole way along.
Same.
Same.
I'm not going to write a 6.
No, and they also make graphs as well.
Yes. This one will be described as uniform.
They would.
It's a special word to use.
Yeah, a uniform distribution. And that means, basically, it just means that they all have the same chance of happening. So it's represented by little sticks on this graph, where probability is along the y-axis, and the random variables are on the x-axis. And for this example, the little sticks would just be all the same height, and that would show that they're uniformly distributed. In something a bit more random, like throwing and catching or whatever, it might have a very different shape, and that would show a different distribution.
Yes. And little tip, everything here, the probability that x equals x will always equal 1, because probability is always equal 1. So what might happen is you might have gaps. It might not be a dice like this, it might be a bit random. You might have gaps, and you've got to work out what these gaps are.
Yeah.
And you have to know that this whole thing will equal 1, so therefore the gaps must be this and this.
Yeah. And there's a few questions sort of using these ideas.
So let's go on to a question now, shall we?
Yeah, let's do it.
Let's prepare one.
Alright, okay.
So we're here with a question about this.
Yeah, about random variables.
Now
We've chosen an asterisk question.
We've chosen an asterisk question.
Is it?
Asterisk questions are designed to be the harder of these sets of questions at the point.
Yeah, and as it wasn't an exam one, chose that.
It says x is a discrete random variable.
Okay.
The probability function, probability of x equals little x, is defined by probability of x equals kx squared.
Okay. We should do a table.
We should do a table. You're going to have x on the top and the probability x equals x, little x.
On the bottom.
Now it says the values for big X are 1, 2, 3 and 4. And what it said is that the probability function is defined by probability of x equals x is in the form kx squared.
So, we have kx squared, where
x is these top numbers.
So,
We're going to have k of 1 squared.
which is just, makes that k.
K of 2 squared.
Makes it 4k.
K of 3 squared.
9k and 16k.
16k.
Alright.
And that's all it's asking you to do. It sounds like a horrific question, but that is all it's asking you to do.
Is there a part 2?
There's a part 2 then.
Okay.
Are you ready?
Yeah.
Part 2 says, explain why the value for k must be 1 over 30.
Okay. Well, something we stated before, we know that all of these added together is equal to 1.
Yes. And that's what you've got to be able to work out yourself. That's what makes this a particularly hard question because it requires a bit of understanding.
So, all these added together would make 30k.
1 plus 4 plus 9 plus 16 is 30.
Yeah.
So k must be 1 over 30. And that is it, you've done it. The only thing that makes this particularly hard is the realising this equals 1 and getting your head around what the question's asking you to do.
Yeah. And there's a bit more of this chapter left though. And
there is, and that's where you use mean, variance and standard deviation.
Of this sort of thing, so get on to that now?
Yep.
Alright, let's do it. We're back, and as promised, doing the mean, the variance and the standard deviation of discrete random variables.
We're going to start with the mean. As you're probably used to by A-level, we start with a new formula.
Yeah, a new formula. Have things changed?
I'm going to use x bar for the mean. It's big X bar.
Yeah.
X bar. And it equals the sum of x, little x, times the probability that x takes the particular value x.
Yeah. Now that looks
horrific.
Horrific. It doesn't look very nice to understand. So what we're going to do is draw a table.
Just draw on this side over here.
Yeah, that's a good plan. I'll swap sides. Right, so we have big X. We have little x like before.
Yep.
And we have an unfair four-sided dice. 1, 2, 3, 4.
Yep.
0.3,
0.2,
0.2,
0.15,
and 0.35. Ooh. Yeah, those will be our values.
To work out the mean of this data, we do the sum of that times that, plus that times that, plus that times that, plus that times that.
Yeah.
So if I do it in, we've got a nice green here.
Alright.
Write it out, you'll have 1 times 0.3.
Yeah.
Plus 2 times 0.2. Plus 3 times 0.15.
And
plus
finally plus 4 times 0.35. And all that equals 2.55. And that'll be our mean. It's as simple as that.
That's our mean. That's about here somewhere.
Yeah. That's roughly the middle of our data. No, that's quite nice.
Yeah, that's quite a nice one. Then we've got the variance, and after that, the standard deviation.
Like the mean. It's another scary looking formula.
But it's not that scary.
It's not that scary. So I can write the formula down first?
Yep, I'll do it up here.
Okay. So we have the
Like
variance
this one.
equals
The
sum.
sigma x minus mu squared times the probability that x takes the particular value.
Now mu is another way of writing x bar.
Yeah.
It's the same as the mean.
So that is that. We'll do it just to clear it up. We'll do. Oh God, I can't draw mu like that.
Yeah.
So that's what that is.
Okay.
So I think it would be easier if we actually draw another table. But instead of writing this 1, 2, 3, 4, we write x minus mu squared along the top.
Yeah.
That'd be a good start, I think. Do you want to draw it underneath that one?
Okay.
Then I'll do the calculation.
So for the first one, we have big X, and we have what will be 1 minus
2.55.
0.55.
And that's all squared.
And that's all squared. But I'm going to do it here, and I'm just going to keep going along, because that's what we're going to do each time.
Okay,
so
I'll do it. 1 minus 2.55 squared
is...
First is 2.402.
I think that's probably enough, that's reasonable.
Okay. 2 minus 2.55 squared. 0.30. 3 minus 2.55 squared. Next one's 0.20. And 4 minus 2.55 squared is 2.10.
Okay.
And then underneath we're going to write in the same values here the probability of getting each one.
Right. So
Which is 0.3, 0.2, 0.15, 0.35.
Right.
And now that makes this so much simpler. Because it's just the same as what we did before, where it was that times that and that times that.
And it becomes that times that, that times that, that times that.
So I'll write it out in green again so it's quite clear.
Okay.
We have 2.4
Let's take the calculator.
times 0.3 plus 0.3 times 0.2 plus 0.2 times 0.15 plus 2.1 times 0.35, and that equals
1.55.
1.55, which is the variance.
Yeah, that's variance.
Now, the standard deviation, as you should know by now, is the square root of the variance, so we can just go straight ahead from this and do that.
We can.
That equals the square root of 1.55,
which is 1.33.
Okay.
And that's that, really.
That is that. Let's do a test yourself.
Yeah, let's do a test yourself question. Yeah. We're back.
Test yourself, page 57, question 1 of this book.
This book, very powerful, very nice.
This time it's actually not from an exam because this is
It's
such
not.
a small unit. This in itself wouldn't be in the exam.
No, it's just all been
But
entwined.
this question would be entwined.
Yeah. So it's just we tried to find one that used most of the skills. I think it uses all of them actually.
Yeah,
That we
it
learned
does.
today.
It does. So just because it doesn't say it's from a past paper, don't think that it won't come up in a past paper because it will. It will just be mixed with other stuff. So this
Yeah.
won't be it if it's the exam paper.
Yeah. So should we do it?
Yep, you can do A and I'll read it to you.
Yeah. Sure.
Okay.
So do you want to take that? I'll grab the pen. Let's do it.
Okay. The diagram shows a fair spinner. Not a spinner that's fair, but a spinner that's at the fair.
Yeah, it's very unfair, in fact.
Let X be the score when the spinner is spun. So on the top, X is the different scores, and you can have score 1, 2 or 3 points. The table shows part of the probability of distribution of X. So the probability of X equals X, and the number 1 is a half. And then question A says copy and complete the table. So you've got to find these two values. There's a picture
Yeah,
in the
picture's a
book.
spinner.
That's how you do it. And
It's divided into 8.
there's 8 sections, and 3 of them are 2, so it's 3/8 is your chance of getting a 2.
And that only leaves 1/8 for 3.
1/8 is for 3. That is it. That is A. Copying and complete the table. Looking
Alright.
at the picture.
Okay, let's do a swap.
Alright. You take that.
You can do that. You can do it in
On
a
the green pen.
Green pen? Yeah.
Alright.
Alright. Okay, part B says calculate the mean of X.
I'm going to put it up here.
Like before, we had the equation, or formula for the equation, which is sigma of X times the probability that X takes the value of little x. Right, so,
It's just like that,
Let's do
times
that.
plus that, times that, plus that, times that. I'm going to write it on that.
yeah,
So it's 1 times a half.
I'll do it in the calculator.
Thank you. Plus 2 times 3/8 plus 3 times 1/8 equals
That equals 1.63.
1.63, and that is our mean.
That is our mean. And there's a part C, so shall we begin?
Yep, I'll put them down. You're going to do it in red.
I'm going to do it in red.
Swap.
Okay.
Part C says calculate the variance.
Okay,
We've done this as well.
we have.
Look at that.
I'll start by writing the formula for it.
Yep. So the formula for variance, sigma squared, is sigma bracket x minus the mean, all squared,
I'm going to write it as
mu. That's
and
u.
times by the...
Probability that x takes the particular value x. So what we're going to do is we're actually going to or what Triv's going to do is he's going to rewrite this table with the bottom value staying the same, but the top value, rather than x, becoming x minus mu squared.
Yeah, like we did
So
last
you
time.
can times that by that and plus it to that plus
Alright, let's do it.
that. Okay. So first he's going to write out what's happening. I'll get the calculator and do it. So we're going to have 1 minus the mean, 1.63 squared, 2 minus the mean, so on and so forth. So I'll do that right now. 1 minus 1.63 equals squared equals. Okay, you ready?
Yeah.
This first value here is 0.397. 2 minus 1.63 squared. The second one is 0.137. And the last one, 3 minus 1.63 squared is 1.88.
Okay.
All three significant figures. Underneath this we're going to keep the values the same, a half, 3/8 and an eighth. And because the formula is the sum of that times that, we're going to do that times that, plus that times that, plus that times that, which I'll do in my calculator now. So we're going to have 0.397 times a half plus 0.137 times 3 divided by 8 plus 1.88 times 1 divided by 8 equals 0.485 to three significant figures.
And that would be our variance.
And it asks for variance, so you don't need to do anything further. Some questions might ask the standard deviation, you simply square root it.
And that'll be that done.
But that's it for this test yourself.
It is.
Now it's time to go on the summary of the video.
Alright.
Not a massive chapter, but let's go.
No, yeah. Right. Summary time.
Chapter 4 of
Discrete random variables.
Yeah, discrete random variables.
Very small chapter. Said that a few times, I think.
Yeah, I've said that quite a lot to say it's a small chapter.
Because it is 3 pages.
It's like 5, yeah.
Yeah.
A few new formulas, unfortunately, it's just the way.
Yeah, but they're not. They make sense, but they don't look very nice.
Yeah.
I think it's the probability that x will take the
Particular value of x, that's really horrible.
It just looks like a big chunk, it's a bit nasty, but
it's not.
It's not, it's okay. So we've got this with 2 formulas. Well, yeah, 2 formulas.
We've got
one for mean.
Mean x bar equals sigma
Sigma.
x times
Probability that x will take
x
the
takes the particular value of x.
And we got this the variance one, or standard deviation, depends if you've got a big square root or not.
Of
X take away mu, which is another way of writing x bar, mean.
Times the probability that x equals x.
Yeah.
And it's in, you've got x.
Yeah, you've got your tables.
X. That's the way the formulas are. So for the first one, it's just the sum of that times that, so that times that plus that times that plus that times that, for how many there is. For this one, it's the sum of that times that. So you got to replace the sigma x on the top, or the x on the top, with x minus the mean squared.
So
and that's what we were doing in the last
I think it's much nicer to draw an extra table.
Yeah.
I think it's much nicer.
Much nicer.
That's what we do.
And standard deviation is the square root of the variance.
So that's fine. And working backwards, before that, we did graphs of discrete random variables and tables, which is what that is, that thing there.
Yep, that's the trick.
Ways of writing it, and what that means.
Yeah, and that was pretty much the video.
Yeah, well, the stuff can have uniform distribution. Remember that as well.
Yes.
You've got to describe graphs in time.
Well, I'll do a scale. I wasn't going to, but I'll do a scale. You can have uniform, and you can have something
A different distribution.
a bit random, something like that. You can have where the points are sort of like this.
Yeah. Quite separated in that one where they all have the same thing, like a fair dice or something.
Yep.
I think that pretty much is it.
That pretty much sums up chapter 4.
Yeah, so that's
that.
That's that. Oh, yeah. He's been Wayne Lack.
And he's been James Durrett.
See you next time.